All right, guys. So I want you guys to see this warm up, okay? Because the number actually it should be 1, 2, and 3, but this third one in particular, I wanted you guys to notice the square root of 17, okay? But first here, if you do square root of 18, all right, we look at our numbers, right? 4, 9, 16, 25, 36, and the only one that goes into it is 9. So we take the 9 out, and it becomes 3 rad 2. And then 40, of course, is 4 times 10. Take the 4 out, and that becomes 2 rad 10. And if you look at radical 17, well, 17 is a prime number. Nothing else goes into it. So there's nothing to do. You can't reduce it. It just stays rad 17. Do not remove the square root and say it's 17 because that's not true. Okay, it's just rad 17. That's it. Okay, so we're going to look a little bit more with quadratic formula. This is quadratic formula part 2. Okay, right? You got negative b plus or minus the square root of b squared minus 4ac all over 2a. I thought that was funny. Okay, so same what, why, and how as yesterday, except for our equation's a little bit different because I want you to see problems that involve what are called prime radicals, and those are radicals that do not reduce. Okay, so you cannot reduce it using a perfect square. All right, so we know quadratic functions look like this. This is the standard form generic version of one. So let's say I tell you to use the x factor to find the solutions to this. So you would say, okay, I'm going to put a 2 here. I got a negative 5. I need two numbers that multiply to 2 and add to negative 5. Wait a minute. Doesn't work. Okay, x factor will not work. So because of that, okay, if x factor doesn't work, there's two options. Either there are no solutions or they're irrational. And looking at the graph, since there are solutions here, I know that they're going to be irrational. All right, so one of them is, what do you think that is? Like, I don't know, 0.4-ish, somewhere around there. This is right here is like, I don't know, 4.5-ish. Okay, not really sure exactly what it is, but we can easily find them using our weapon of math destruction, which of course is the quadratic formula. Okay, so let's go ahead and do that. All right, this was kind of funny to me, right? They forgot the quadratic formula. I forgot about the bodies. All right. So this is the same problem. We just saw the solutions were like 0.4-ish and 4.5-ish. So let's use the quadratic formula. So we'll plug in our values. So we identify A, B, and C. So let's plug in negative 5. That's B again, negative 5. A is 1. C is 2. And then A is 1. Okay, now we'll look at that and maybe we'll put it in Desmos or do whatever we need to get that value. Okay, but I look at it and say that's 25 minus 8. And 25 minus 8 equals 17. And that right there is a negative and a negative, which is going to be positive 5. So when I reduce it, I end up with 5. That's 17. And that's 2. Okay, so you look at radical 17 and you say, okay, can we reduce this? Is this reducible? We can't. Doesn't work. So we're done. We don't have to reduce square root of 17. Okay, so we just go ahead and split it now as 5 plus rad 17 over 2 and 5 minus rad 17 over 2. Okay, and then let's look at the decimal version of each of these. We'll just plug them into Desmos. Right, and you guys should know how to do that by now because we've done it so much. and we get around 4.6, and I think I said 4.5-ish. And then this one is 0.4, and that's exactly what I said. I said around 0.4-ish. Okay, so in order, all right, it looks like we've got incorrect answers here, which I'll change in a second. Okay, but we should have 4.6 and 0.4, right? Because here's the graph, and my graph is right there around 0.4 and right there around 4.6. So let me go ahead and fix that real quick. And let's see, I want to fix something else. I would do the same thing there. Let's see, what number was that? 23. Text box 18. All right. So we already did this one, and we verify on Desmos with the graph that indeed the two roots are 0.4 and 4.6. Okay, so it actually makes it easier when you can't reduce. Like on here, we have that 17 that's not reducible. Okay, I mean, it happens. Not all square roots are reducible. All right, so same thing here. We're going to use the quadratic formula. So let's plug in our values. So my A is 2, B is 1, and C is negative 5. 2, 1, negative 5. So B, I'm going to put a 1 there. Again, that's another B. Minus 4AC, so 2 times negative 5. And then over 2A, so that's 2. Okay, so either put this into Desmos or use mental math. So 1 squared is 1. And since there's 2 negatives, I'm going to make it a plus. So 1 plus 8 times 5 is 40. And that's going to give me 41. Okay, so if we reduce it, that's going to stay negative 1. This will be a 4. We got square root of 41. That's a 4. So we've got negative 1 plus or minus rad 41 all over 4. Okay, we have this 41, and we ask ourselves, hey, can we reduce square root of 41? So we think about 4, 9, 16, 25, 36. Do any of those go into 41? And they don't. I can't even think of a number that goes into 41 because it's prime. Okay, so since that's true, then we're done. But we'll go ahead and rewrite them as our two roots, our two x-intercepts. So we got the plus, and we've got the minus. And then we go from here by using Desmos, and we put it in decimal form. Okay, so you guys should be able to do that. Okay, you should probably check it on Desmos. Try to do it to get the same answers I get. And I get around 1.4. And here I get around negative 1.9. Okay, and we'll check the graph here in a second. So using set notation with the braces, least to greatest, negative 1.9, and then 1.4. So let's check it. So here's the function. This is this function right here. So negative 1.9 is right there, and then 1.4 is right there. So it looks good. Okay, so, but I mean, for the most part, what I wanted you guys to see, of course, was more examples by using the quadratic formula, but also seeing a square root that doesn't reduce. What students like to do is even though it doesn't reduce, they'll just remove the square root and make it 41. You can't do that. Okay, there's got to be a reason why the square root is reduced. Like if that was 49, then yeah, you can remove it and it becomes a 7. But it's a prime number. You're taking the square root. You can't break it apart with any perfect squares. All right. Thanks.